Good evening, all of you. Welcome to a wonderful session here. Simple techniques to solve electric circuits. I hope you enjoyed the previous two sessions, right? So a warm welcome to all of you once again to India's most comprehensive e-learning platform, that is BYJU'S Exam Prep. Okay. So if you are a newcomer, please go through my part 1 and part 2 sessions. Okay. This is part 3 I'm discussing today on the simple techniques to solve electric circuits. In part 1, I spent some time on the network reduction and the current division, voltage division, and of course I also introduced one important technique called jumping technique. In part 2, I explained about the mesh analysis, node analysis by taking some different cases. Okay, super mesh also I discussed, and I explained already that why super mesh is not supposed to be applied in the competitive exams. So please go through those sessions if you have any doubt. Okay, and in today's session, of course, in the last session I did not discuss the supernode analysis. I told you that supernode as well as some other alternative technique, that is called a reference node shifting method. I'm going to explain. I told that, okay, in this particular session I'm going to discuss, and around 15 to 20 problems I'm going to solve in today's session. So please stay tuned till the end of this particular session, and I'm sure that you become master in solving any circuit with less amount of effort, with less amount of time, you are able to solve. I can assure you that any circuit you can solve easily. Okay. Well, before I get into the topic, okay, I would like to introduce myself once again because there are so many newcomers might be joined here today. So let me introduce myself once again. I'm Dr. Muneender Erukulla. I did my master's and PhD both from NIT Warangal. I have 22 years of experience in GATE, ECE, PSUs. I taught more than 250 batches for GATE, Engineering Service Exam, and PSUs across the country. Okay. I visited USA, Hong Kong, Malaysia, and Korea to present some of my research articles at the most prestigious IEEE and IET international conferences. I guided and motivated 2 lakh plus students by visiting 500 plus engineering colleges across the country. And I'm presently supervising 4 PhD scholars on the most important and advanced topic called smart grid technology using artificial intelligence techniques. Okay, and my interesting subjects, okay, my area of expertise in GATE, ECE, PSUs is that there are 3 subjects: network theory, control systems, and power systems. Okay, well, so subscribe to the YouTube channel BYJU'S Exam Prep to get more updates. And whenever I take the new sessions, okay, on control systems and power systems and network theory, these 3 subjects I may be taking some important topics. I may be discussing important topics in the near future. So please subscribe to the channel and click on the bell button. Definitely you will be getting the notifications. Okay. And some more important information is that now, November 13th onwards, there is only one channel. There is no Hindi English channels, only one channel for ECE, EEE, Instrumentation, and Computer Science together, one channel. Of course, for Mechanical and Civil, there is another channel. Okay. So you can just subscribe to the YouTube, the channel, and link you can find in the description. One more important announcement is that there is a scholarship test on 12th November at 8 p.m. If you score well, you will get up to 90% scholarship in the programs that are offered by the BYJU'S Exam Prep, okay, which are related to the GATE examination preparation. Okay. Well, you have one GATE preparation ebook you can download. That link is provided in the description. You please find the link and you can download that book. And there is a workshop, okay, free workshop on most important topics, okay, by experts. A senior faculty will come and deliver the lecture. That's a free lecture, free workshop. Okay, the link is available in the description, and please click on the link and register yourself. And I told you already that scholarship test is available. The link for the scholarship test is given in the description. Please don't miss that. Okay. And the last but not least, the mock test. Okay. Test series is available here, offered by the BYJU'S Exam Prep. get unlimited access to full-length mock test as well as subject-wise test. In the description, the link is already provided. Please go through that. What do we provide generally in the mock test or test series offered by the BYJU'S Exam Prep is that 10 mock tests for GATE and 25 to 30 subject-wise test. For ECE also here 16 mock tests, but 25 to 30 subject-wise test will be provided. Okay, so don't miss them. Now, let us see here. If you have any doubts, anything you want to discuss with me, I'm giving my Telegram group channel here, Telegram channel group. Professor Muneender GATE is my group. You can join, and whenever you get the doubt, you can interact with me. Okay, please go through the lecture. The lectures are also I'm posting in the group. Okay, you can go through them. I discussed the transient analysis in the past, and those lectures are also available, and you can access them, and whenever you have a doubts, you can also interact with the group itself. Understand all of you, okay? Well, now in the node analysis, the case 3, case 1, case 2 we already discussed, but now case 3. Let us try to understand here. Look at this. This is what the network given. So how do you solve this network? How many nodes are there? 1, 2, 3. Okay? Node analysis. We are discussing what? Node analysis. Now to solve this network, there are 2 methods we can apply. The first method is that, method 1, super node analysis. Why super node analysis? If I take this one is 0, these 2 nodes will become principal nodes, and between 2 principal nodes, there is an ideal voltage source without any series resistor. Without any series resistor. You understand all of you? When there is no series resistor for any ideal voltage source that is connected between 2 principal nodes, usually most of the times you apply the super node analysis. But of course in this session I'm going to discuss the other alternative techniques better than the super node analysis, which will save a lot of time, and that can be applied in the competitive exams, because in the competitive exam the time is more important. As all of you have to save a lot of time. Okay, so let us see now here this particular one using the super node analysis. The first step in the super node analysis is that first I will discuss super node, because sometimes you cannot escape the super node also. Sometimes you cannot escape from the super node. Certain cases you have to go for super node analysis. I'm going to discuss those cases also. You understand all of you? I'm going to discuss those cases also. So please stay till the end of the session. I'm sure that you're going to get a lot of valuable inputs. How to solve the networks using simple techniques. Okay, well, so now here, please put in the comment box if you have any doubts. Okay, wherever you get the doubt, don't hesitate. Okay, I can definitely clarify your doubts by taking different examples. So don't hesitate. Okay, please keep in the box. Okay, well, hope you're all following. Okay, so now you can see this. Super node analysis, according to that, the step 1 is first you express the node voltages in terms of this particular voltage source value. That is the first step. So what do you get now? Tell me. V1 minus V2 is equal to E3. Do you agree with that? Yes or no, all of you? V1 minus V2 is equal to E3, where E3 is a known value. If E3 is 10 volts, V1 minus V2 is equal to 10 volts. Isn't it? One equation you got. But how many equations you require? 2 equations, because there are 2 variables. Yes or no, all of you? Okay. Now, what we do is, after expressing this, you suppress this particular voltage source. Suppressing means what? Replace the voltage source by its internal resistance. Suppressing is nothing but what, Nana? Suppressing, deactivating, replacing by its internal resistance, all are same. But what is the internal resistance of an ideal voltage source, Nana? It is 0. Okay, 0 ohm. 0 ohm refers to what? Short circuit. That means I'm going to replace the voltage source by the short circuit. Which voltage source? The voltage source which is connected between, the voltage source which doesn't have a series resistor connected between 2 principal nodes should be suppressed. That means replaced by its internal resistance. Look at this now. That's what I did. I suppressed here. I replaced with the short circuit. As soon as you replace the voltage source by the short circuit, the node 1 and node 2 become same, a single node. That single node is called super node. You understand? So what you do is, to obtain the second equation, because there are 2 variables, you already got one equation here. To obtain the second equation, what we do is, we apply Kirchhoff's current law at super node. You understand all of you by maintaining the previous branch currents. What was the branch current here earlier? V1 minus E1 by R1. What was the branch current here? V1 by R4. What was the branch current here? V2 by R5. What was the branch current here? Suppose if it is E2, then V2 minus E2 by R2. So that's what we did here. All currents are leaving. Therefore, plus V1 minus E1 by R1 plus V1 by R4 plus V2 by R5 plus V2 minus E2 by R2 is equal to 0. So equation 1 and equation 2. There are two equations you have obtained. You understand all of you? Solve these two equations, you will get the value of V1 as well as V2. You understand all of you? Okay. So there are three nodes. When I take a bottom node as a reference node, there are two variables I need to solve. So n number of nodes, n minus 1 equations required to solve this network. You understand all of you? Okay. Well, now let us see a different case here, a reference node shifting method. Sometimes it is very much advantageous in reducing the number of equations if you shift the reference node from bottom node to any other desired location. Look at this, all of you. Instead of selecting the bottom node here, I am selecting this node as a reference node. You know that this is a known value. For example, if it is 10 volts, when you take this one as a reference node, obviously this voltage is known, that is E3. E3 is nothing but what now? 10 volts. If E3 is 10 volts, then this node voltage is available here. Okay? But what is the other node that is not available here? The voltage at V. You understand all of you? Out of 3 nodes, when I take this one 0, this voltage is known now that as E3 because there is no series resistor. If there is a resistor here, hi Ravi Shankar. Yes, reference can be given at any node, Ravi Shankar. There is no problem, Ravi Shankar. Any node can be selected as a reference node. Got it, Ravi Shankar? Okay, reference node can be anything, Nana. Any node can be selected as a reference node. There is no restriction at all. Got it? Okay? Well, so when you take this one as 0, because there is no resistive element here, directly the voltage source is available here. That is why it will become what? 10. So out of 3 nodes, this is 0, this is 10. Only one node variable is unknown here. That I am calling it as what? V. So 3 nodes, only one variable is required. That means one equation is required. N number of nodes, n minus 1 equation, that condition fails in this particular case. You understand all of you? N number of nodes, n minus 1 equations, that condition fails. Especially when there are ideal voltage sources in the given network without having any series resistor, Nana. That is very, very important to understand. So that is an advantage actually. Whenever there are some ideal voltage sources with no series resistor, you should feel happy because the number of equations will reduce if you properly choose the reference node. You understand? Okay? Well, so look at this now. According to reference node shifting method, now I would like to write the KCL at this node. You understand all of you? What happened here? V minus E3 plus E1 by R1. That is what the current. Leaving here. V minus E3 by R4. That is what the current here. Okay. V minus 0 by R5. That is what the current here. Okay. V minus 0 plus E2 by R2. That is what the current here. Following all of you? Okay, Ravi Shankar, you are saying something, sir, for previous 2 nodes, so we should get only one equation, no, sir. Previous one 3 nodes, na? See, you have 3 nodes all the time. Look at this. You have 3 nodes all the time. This is also 1, 2, 3. You understand? Okay. 3 nodes are there. Always 3 nodes are there. 3 nodes, 2 equations, generally that is what the, yes, according to n minus 1 formula, I'm telling you, yes, that is what it is true, but that condition fails, Ravi Shankar. I have proven that if I select this one as a reference node, because it is an ideal voltage source which doesn't have any series resistor, you know this voltage. Whereas in the earlier case, when you have taken the bottom node, the other 2 node voltage we do not know. Only we know the difference between the 2 nodes. Okay, the difference between the 2 node voltages we know, that is E3. But we do not know what is V1, what is V2. The V2 are two unknown values are there. I think you understand. That is why two equations you will get there. But here, because I conveniently chosen the reference node here, okay, one of the terminals of the ideal voltage source is selected as a reference node. That is what actually the reference node shifting method. You understand? That is what reference node shifting method. According to reference node shifting method, I always recommend and suggest that select one of the terminals of an ideal voltage source which doesn't have any series resistor. Here, this is also ideal voltage source, but it has a series resistor. This is also ideal voltage source, but it has a series resistor. This is also ideal voltage source, but it doesn't have any series resistor. You understand, all of you? That is why I always recommend, according to reference node shifting method, okay, select one of the terminals of the ideal voltage source which doesn't have any series resistor as a reference node. Then obviously the other terminal of the ideal voltage source is obviously available. Therefore, the number of equations will be decreased. You got it? Because ultimately we have to save the time. When number of equations are getting reduced, the computation time will also getting reduced. Yes or no? Okay. Well, so you solve it now, you get the value of V. But the question is, he's asking what is V1, V2 by taking the bottom node as a reference node. But for our convenience, we have selected this node as a reference node and this is 10 volts, this value we determined. You understand, all of it? This is how we actually got. We got the solution for this, but we are supposed to answer this particular question by taking the bottom node. What are the values of V1, V2? Yes or no? Okay. So for that you can see here. For example, if E3 is equal to 2 volts, okay. Here I have taken 10 volts. Okay. Let's take 2 volts here. Let's take 2 volts here. You understand? Okay. If it is 2 volts, after solving for V, you got, let us say, 10 volts. Let us assume. Let us assume that taking this one as a reference node. This is already 2 volts, which is a known value. Assume that after solving that equation, you got 10 volts. Okay, now we are supposed to answer by taking this one as a reference. That means you are supposed to convert this node into reference node. How can you convert the non-reference node into reference node, Nana? You reduce the voltage of this particular node by, okay, what is its node voltage? 10 volts. Reduce it by the 10 volts. When one particular node voltage is reduced by 10, then all remaining node voltage will be reduced by the 10 or not. Yes or no, all of you? Therefore, so what you got here, it's already 2, therefore 2 minus 8. This was already 0, therefore 0 minus 10. That's it. So you got here the potential difference 2 minus 10, 2 minus 10, minus 8. Here, minus 8 minus 0, minus 8. Okay? 0 minus 10, minus 10. Minus 10 minus 0, minus 10. 2 minus 0, 2 volts. You understand, okay? Minus 8, minus of minus plus 10. Okay, this is also 2 volts. That's it. Branch voltage remains same. Okay? Negative voltage, yes, you may get negative voltage. Negative voltage means what, Nana? Ravi Shankar, what do you mean by negative voltage? Here actually this is 10 volts. You are supposed to reduce that voltage by 10 so that you will get 0. Or you add minus 10, you will get 0. When you are adding minus 10 to one particular node, then every node must be added by the same value or not. That's it. Yes or no, all of you? So that is how we can solve the problem. You understand, all of you? Okay. So now, examples. The minimum number of equations required to solve the network using mesh analysis, using the node analysis, can we find here? Minimum number of equations required to solve using mesh analysis and node analysis. I told you already that. Look at the loops here. First loop 1, 2, and 3. There are 3 loops according to mesh analysis. According to mesh analysis, the minimum number of equations, okay, in mesh analysis will be 3 loops, 3 fundamental loops, okay. Well, Vikram, how are you? You understood? Very good, very good. Minimum number of loops Okay, minimum number of equations required in mesh analysis. There are 3 fundamental loops, but 2 current sources, 3 minus 2, 1 equation is enough using mesh analysis. But what about the node analysis here? 1, 2, 3, 3 nodes. If you take 1 as a reference node, V1, V2, okay, node analysis will give you 3 minus 1, 2 equations required. Okay, well, coming to this now. According to mesh analysis, 3 loops, 1, 2, 3, but 3 current sources, 3 minus 3, 0 equations required. But according to node analysis, 1, 2, 3. Okay, are there any ideal voltage without any series resistors? You have 2 ideal voltage sources, but they have series resistors. Therefore, there is no chance of getting, the n number of nodes, n minus 1, will not get violated. N number of nodes, n minus 1 equations is valid. Okay, so 3 nodes, node analysis will give you 3 nodes, but 1 node is reference node, 2 equations required. So what is the best method to apply here? Tell me, in this particular problem, mesh analysis is the best one. Okay, whenever a network is given, or if somebody is asking you a question that which method is the best method, don't conclude immediately that mesh analysis is best or node analysis is best. Not like that. You tell, first of all, you give me the network, then I will decide. I must know what is the network, how many current sources are there, how many ideal voltage sources are there, whether ideal voltage sources without any series resistor is there or not. Based on that, I can conclude whether the given network is really, solved by mesh analysis or node analysis, or which is the best method for the given network. I can tell only once the network is provided to me. You understand, all of you? Okay, Ravi Shankar. Okay, good. Mesh analysis is the best method, right? Very good. Now coming to this one. How many equations? 1, 2, 3. Mesh analysis will give you. Can you repeat the current source with resistance? Current source with a resistance, where is that? Here? No, voltage source with a series resistor, I am telling you. Current source with a series resistor, okay, fine. Okay. Which one is 0? Current source with a series resistance. Oh, number of Y 0 equations. Okay, Y 0 equations. Look at this. I told you the minimum number of equations. Last session I told you already, but I think you were not there. Please go back to my part 2 lecture. You will understand. Minimum number of equations required in mesh analysis will be L minus number of current sources. Number of current sources. I can also prove why it is 0. I'll tell you how it is. But you answer my questions whenever I'm asking here. You please answer my question. Say this is 10 amperes. Say this is 3 amperes. Say this is 5 amperes. Okay, look at this carefully. Suppose if I select the loop current, okay, if I select the loop current, something like this, okay, I1, got it, I2 and I3 like this. Following? Ravi Shankar, tell me now, what is I1 value? Can I say, because this element belongs to only first loop, can I say I1 is equal to 5 ampere? I got the answer. I don't have to solve any equations. Fine. Now, what about this 3 amperes? It belongs to only second loop or between second and third loop? Tell me. Okay, what is the current passing through 3 ampere? Tell me, only I2, right? I3 is not passing. That means I2 is equal to 3 ampere. I know the value of the I2 also, right? What is the, okay, the current passing through, that loop current passing through this particular current source, Nana? Only I3, because this element belongs to only what, third loop? Yes, only second loop, right? Vikram, very good. No, Ravi Shankar, you said second and third loop. No. The 3 amperes belongs to only second loop, according to the selection of loop currents. according to selection of loop current. Suppose if you select like this, this is I3, this is I2. Yes, 3 ampere belongs to both second and third loop, Nana. But I have selected for my convenience, say this is I2, but this is what I3. Look at this. This is what I3. You understand, Ravi Shankar? Is it clear? Vikram, very good. Only second loop is correct, Vikram. Ravi Shankar, you understand? Please respond quickly. You understand, Ravi Shankar? Yes. Now, I3 value. See, this element belongs to what? Only third loop. So, I3 can be equal to what, none other than? I3 is equal to just 10 amperes. You don't require any equation to solve. You already got the values. That is why I was telling in the last session clearly that minimum number of equations required in mesh analysis is L minus number of current sources. L is nothing but fundamental loops. 1, 2, 3 loops, fundamental loops are there. Okay? But 3 minus current sources, 3 are there, therefore 0 equations. I think you followed now. Okay? Now, coming to this one now. Similarly, 3 loops are there, 1 current source, therefore 2 equations required. What about node analysis? 1, 2, 3, this is 0, this is 1, 2, V1, V2. Therefore, node analysis, you require 3 minus 1, 2 equations. So, which method is best? Any method is okay. Whereas in the previous case, mesh analysis is the best method because it was giving 0 equations. Here, mesh analysis is giving 2 equations. Node analysis is giving 2 equations. Yes or no? Very good, Ravi Shankar. Now, coming to this particular problem. Okay. 1, 2, 3, mesh analysis will give you, okay, 3 minus 1 current source, therefore 2 equations required. Node analysis. Usually people, node analysis means suddenly they will tell that 1, 2, 3 nodes, therefore 3 minus 1, 2 equations required. But be careful before you give that answer. Okay, whenever you are counting minimum number of equations using node analysis, the first point you have to check is whether the circuit contains any ideal voltage sources without series resistors. Look at this. This is an ideal voltage source, no doubt, but it has a series resistor. Okay, this is an ideal voltage source, but it doesn't have any series resistor. Yes or no, all of you? Therefore, if you choose one of the terminals of the voltage source as a reference node, the other node voltage is obviously available. Only this node is not available here. Therefore, only one equation. Though there are 3 nodes, even though there are 3 nodes, but only one equation is required. N number of nodes, n minus 1 equations will get violated here because the network contains an ideal voltage source without any series resistor. So therefore, only one equation is enough. Therefore, which is the best method here? Node analysis is the best method. What are the minimum number of equations required means? Minimum of the equations here 2 and 1, that is 1 only. Sometimes in the exam he will ask you what are the minimum number of equations required. That's it. He will not ask mesh analysis, using mesh analysis or using node analysis. Simply he will ask what are the minimum number of equations using any method that you like. You like super node, you like, let us say, reference node shifting method, okay, or mesh analysis, anything it might be. But you have to tell minimum number of equations. You understand, all of you, okay? I can solve this problem using one equation. I have a possibility here. Yes or no, all of you? Okay? Well, very good. If you have any doubts, please put in the comment box. I can answer those questions, okay? These are all very, very, important and fundamental concepts. You can play with the networks if you understand these fundamentals, Nana. Okay? Well, now, this is another important question here. How many equations you will get using mesh analysis, tell me? There are no current sources. When there are no current sources, L number of equations required. L, fundamental loops, 1, 2, 3, that's it. 3 equations required. Node analysis, you must be careful here because there are 2 ideal voltage sources without any series resistors. If you take this one is 0, say this is 10 volts, this is 5 volts, let us say, this value is obviously known, yes or no? This value is obviously known. Got it? Okay. Now, this is an unknown value. This is an unknown value. It is forming a super node. Because between 2 principal nodes, when there is an ideal voltage source, when there is an ideal voltage source, okay, without any series resistor, that leads to the formation of the supernode. You understand? But finally, how many equations required? 2 equations using supernode. But if you want to escape from the supernode, what you can do is, okay, you try to here, this one can be taken as 0, then at this time it will become 5 volts, but now this is no longer a reference node, then it is no longer going to be 10 volts here, but now this is an unknown value, this is an unknown value, now it will become V1, this is V2, here also there is no series resistor, yes or no? There is no series resistor, this will form the supernode again. So I told you that sometimes you cannot escape from the supernode formation. You understand, all of you? Because there are 2 ideal voltage sources located at different places. You understand, all of you? When there is no common node between the 2 voltage sources. Okay, 2 are differently placed. So such time, what will happen here? If you want to escape from the supernode, it cannot be possible. So now here, once again, the 2 equations are mandatory. Here, even though you shift the reference node to some other desired location, okay, still it will form the supernode. Sometimes you cannot escape from the supernode analysis. That is why we should also learn supernode analysis. You understand, all of you? We should also learn supernode analysis. We try our best to avoid the supernode, but sometimes it may not be possible. You understand, all of you? Okay, well. So in the GATE examination, it was literally asked like this. How many equations are required to analyze the following network? This is what the question. Can anybody answer quickly here? How many minimum number of equations required? A, 4, B, 3, C, 2, D, 1. Please tell me. How many equations are required? Vikram, so if you use supernode, number of equations required will be n minus 1. No n minus 1, because here there is one ideal voltage source, right? There, what happens here is, though there are 4 nodes, okay, but when you take one node as a reference node, here this value is known value. Okay, so one is 0, the other is a known value. Out of 4 nodes, 2 values are known, the 2 are unknown. That's why 2 equations are enough, Nana. Vikram, do you follow it? Do you follow, Vikram? Please respond quickly. Very good, Vikram. But you answered this question, Vikram. You answered this. How many equations are required? This question was asked in the GATE examination. Minimum number of equations required to analyze this network. How many equations are required? Option C. Let us see here. Using mesh analysis, how many equations required? This is the voltage source, okay? Clearly understood, right? 1 loop, 2 loop, 3 loop. There is one more loop coming to picture. This is not a non-planar network. This is a planar network. So 4 loops will come into picture because there is one element. This is an inductor. If you draw it outside, if you draw like this, if you draw like this, okay, one more loop is formed. Therefore, you get what? 4 equations. So mesh analysis will give you 4 equations. Always try for mesh analysis and node analysis. Then whichever is giving minimum, that is going to be the minimum number of equations required to analyze the given network. You understand, all of you? Okay, well. Now, node analysis, let us try to understand. How many nodes are there? 1, 2, 3, 4, 5. How many nodes are there totally? 5 nodes are there. Okay, how many nodes are there totally? 5 nodes are there. 5 nodes, 5 minus 1, 4 equations usually. That is a common answer people will get into mind. Okay, n number of nodes, n minus 1 equations, and option A is readily available, it will definitely mislead you. But in fact, this is not the correct answer. Because this circuit contains an ideal voltage source without any series impedance or series resistor. Yes or no? Without any series impedance or series resistor. Okay, therefore, you select one of the terminals of this voltage source as a reference node. Obviously, I can select the bottom node, and this value is a known value. Out of 5 nodes, one is 0, the other is E. Only the other 3 nodes are not available here. Therefore, 3 equations are enough. Minimum of this 3 and 4 is 3. Therefore, option B is correct. Ravi Shankar, you understand where you have done the mistake? Understand? Okay? This is literally the question was asked in the GATE examination. You understand? Okay? Well, so that is why I am explaining you. 1 mark question may come in any direction and we can't predict. The concept must be very clear. You understand, all of you? Okay? The concept must be very clear. So GATE always, tests your concepts and fundamentals. They're not going to give you a big circuit and, ask you to solve the, the circuit here. They give you simple circuits only. The only thing you have to save the time. They will give an opportunity to save the time, but you have to utilize that opportunity. So that will come only when you are thorough with the concepts. Got it? Okay. Now, last example in this. Now look at this here. Tell me here. How many equations required? 1, 2, 3, according to node analysis. 3 nodes, but don't come to a conclusion immediately the 2 equations, because there is an ideal voltage source which doesn't have a series resistor. Suppose if it is 10 volts, if I take this one 0, this is going to be 10 volts, and this is what the unknown value. Only 1 equation is enough using the node analysis. But mesh analysis, 1, 2, 3, and 4, you understand? No, mesh analysis will give you what? 4 equations. So sometimes mesh analysis will give less number of equations. Sometimes node analysis will give you the less number of equations. Understand, all of you? Okay. Well, now we are going to solve the problems. Shall we quickly solve the problems? I think you are ready with the calculators, right? So I will definitely give you the answers because the answers are readily available with me. I will write the required equations and will give you the answers directly, because it will take a lot of time. If I just do the solutions online, it will be very difficult. Okay, but you must be ready with that. Okay, quickly try to give the answers from your end. Okay, so I gave my the channel group. Please join this and put your questions. What are the doubts you have in that group? You can you can interact with me. I will post the PDF of this particular session also in the group. Okay, last 2 sessions and this session, all 3 I will put the PDFs in that particular group. Okay, you can follow the group. You can follow, you can join the group and then access those PDFs. Okay, well. Now, find VAB. We'll try to do first 2 problems. I will apply both mesh analysis as well as node analysis. But third problem onwards, okay, by looking at the circuit, we must decide immediately whether node analysis is the best method or mesh analysis is the best method. And accordingly, we have to apply. You got the point? Okay, well, so let's do this now. First, I would like to apply the mesh analysis. Find VAB using mesh analysis. Okay, single loop network, I can easily solve. Tell me here, -3 into I, okay, plus 10 volts. I follow different convention, I don't know what you follow. -5I, -8, okay, plus 30 is equal to 0. Or else, I can directly apply without writing this equation, because the single loop equation, total voltage by total impedance. So 30 volts is taken as here because minus plus, okay, this is also minus plus, but this plus minus. So 30 plus 10 minus 8 by 3 plus 5, this 30 plus 10, 40, 40 minus 8, 32 by 8, that is 4 amperes. Is it clear? Okay, 4 amperes. Got it? Okay. Now tell me here, when it is a 4 amperes, the voltage across this one, when this is 0, this is how much, Nana? 30 volts. Okay, or this is how much, Nana? 8 volts. Okay, what is the current flowing here? 4 amperes. 4 amperes means plus minus 4 into 3, 12 volts. 4 into 3, 12 volts. Now jump from this point to this point. What will happen here? You are jumping from higher potential to lower potential. Therefore, drop the voltage. 30 minus 12. How much it is? 30 minus 12. How much it is? 18 volts. Okay. Now jump from this point to this point because you require VAB. This is plus minus VAB. Okay. So this node voltage is nothing but VAB because B is taken as 0 here. Therefore, jump from now negative terminal to positive terminal. Look at this, negative to positive. Take the voltage. 18 plus 10 is nothing but what, Nana? 28 volts. So simply VAB is nothing but 28 volts. Ashok, yeah, good evening. You are a bit late, it looks like, okay? Well, I hope you are following, okay? Well, now, well, what about VAB? Even you can follow from this also, okay? This side also you can come. Look at this. I will also solve this from this side also. Look at this. Yeah, Chandu, hi Chandu. 28 volts is correct answer, Chandu. Well, tell me here, 8 volts this is, and the current flowing here is how much, Nana? 4 amperes. 4 into 5, this is plus minus 20 volts. Okay, you're jumping from this node to this node. I told you last day, jumping technique. Jumping technique can be applied anywhere. That is the greatest advantage, that you jump from one node to other node. Okay, 8 volts, and you're jumping from lower potential to higher potential. So take the voltage. 8 plus 20 is nothing but what? 28 volts. So I solved this problem using mesh analysis. Otherwise, I can solve using the node analysis, right? So this is what? Plus minus VAB. So this node voltage, when B is taken as 0, this A is going to be VAB directly. So let us apply. So VAB minus 8 by 5 plus VAB minus 10 minus 30 by 3. But try to apply always the inspection, Nana. Don't apply this one. Apply always what? Inspection. Inspection will save time all the time. Better you have a practice. VAB off. There is only one variable, 1 by 1 matrix, 2 variables, 2 by 2 matrix, 3 variables, 3 by 3 matrix you will get. Following all of you, okay? One variable, only 1 by 1 matrix. So VAB off, this is 1 by 5, okay? And then 1 by 3 is equal to, touching positive sign first, plus 8 by 5. Touching positive sign first here, touching again positive sign first here. Take both the voltage source values. So 10 plus 30 by 10 plus 30 by this 3 ohm. So solve it. I'm sure that you will be getting here VAB is equal directly 28 volts. So using node analysis and mesh analysis. Yes, Chandu, I think you got 28 volts even using the node analysis, right? Chandu, Ashok, Vikram, Ravishankar, please respond quickly. I think you got this answer, right? Okay, the remaining people can also respond. Please try to involve in the calculations. Okay, the hand calculations will be the secret of success, I'm telling you. Most of the people, have a tendency that they watch. So problems you cannot watch, you have to involve and solve them. Then only it is possible. Yes, Ravishankar, previous slide, okay. Any problem in the previous slide, tell me. The jumping technique, you have any doubt? Jumping technique is very simple. If you know one node voltage, from that node to any other node you can jump. Any doubt, Ravishankar? Please respond quickly. Yeah, very good. Well, now find V1, V2. This example also, see, these are all simple problems, okay? But I will try to explain you in multiple ways so that you will get an idea. Okay, whenever you come across a network, you will get an idea, okay, to solve the given network in an easy manner. So that's why I'll try to solve in different ways. The same problem I'll solve three, 4 different ways I will solve here, okay? Look at this now. Well, find V1, V2. V1, V2. Taking this one as 0. I can find the node voltage using mesh analysis also. Because generally node analysis will take 2 equations because 2 equations are required here. How many equations are required using node analysis here? 2 equations. Minimum number of equations required to solve this network using node analysis 2. But minimum number of equations required using mesh analysis, how many? Tell me. 1, 2, 3, 3 minus 2 current sources. Mesh analysis will give you 1 equation, 3 minus 2, 1 equation. Node analysis will give you 2 equations. Yes or no? Yes or no? Therefore, I think you followed this right. Mesh analysis will give you 1 equation. Node analysis will give you 2 equations. Got it, all of you? Okay. Whenever you answer this, don't reduce the network. Don't apply any source transformation. Don't apply any star delta transformation. Don't reduce the network. Take the network as it is and try to answer that. That is what the intention of the person who gave the problem. Okay. Finding the minimum number of equations. For your convenience while solving, you can reduce it. That is a different story. But to answer minimum number of equations required, you can't reduce and tell the answer. You must take the network as it is given and you have to answer it. Okay, Ravi Shankar. Yeah. Node analysis will give you 2 equations. Mesh analysis will give you 1 equation. Is it okay? Well, so I will follow first mesh analysis. Look at this. Because finally V1 is what actually voltage across 2 ohm. V2 is nothing but what voltage across 7 ohm because this is taken as 0. Yes or no? So I select the loop currents like this. This is I1 and this is I2. Okay. I select the third loop current so that it does not pass through any other current source, because if it is passing through any current source, again it leads to the super mesh analysis. Okay, current source must not be a common element between any 2 loops. So I will select the I3 like this, or I3 or I, whatever it might be. So I1 is 1 ampere, I2 is 4 ampere. So I got these values, that's it. Only one equation is required to solve this now, that is minus 6 I3. Okay, minus 7 times I3 minus, what is this value actually? 4, right? I3 minus 4 minus 2 times I3 minus 1 equal to 0. Please solve this equation 1 and I'm sure that you will be getting I3 is equal to 2 amperes. You got that, all of you? Okay. So once you got that I3 is equal to, okay, I3 is equal to 2 amperes, okay, tell me now. When it is 2 amperes, okay, when this is 1 ampere, what is the current flowing here? 1 minus 2 downward direction or 2 minus 1 upward direction. Okay, this is 4 ampere, this is 2 ampere, then 2 minus 4 is downward direction. Yes or no? And this current will give you, that is minus 1 ampere, this is nothing but minus 2 ampere. Then the current flowing through 2 ohm, this is actually minus 1 ampere, will give you the polarities plus minus, minus 1 into 2, minus 2 volts. V1 is also plus minus V1. Therefore, V1 is equal to minus 2 volts. You understand, okay? Similarly, the other element 7 ohm, what is the current flowing here? It is minus 2 amperes, plus minus, because current direction will determine the polarities of the voltage across that element. Minus 2 into 7, according to passive convention, minus 2 into 7, minus 14 volts, but V2 is nothing but plus or minus V2. Therefore, same polarities, plus, plus, minus, minus. Here also, plus, minus, plus, minus. There is no mismatch, right? There is no mismatch at all, okay? If there is a mismatch, you have to put minus sign, but there is no mismatch. So direct polarities are same as it is. Like these are the actual polarities, these are the desired polarities. When there is no mismatch between the actual polarities and desired polarities, you can take directly the value. V2 is equal to simply what? Minus 14. If there is a mismatch, then you have to multiply that voltage by minus 1. You understand, all of you? The polarity will be reversed. Okay? So this is how you can solve using the mesh analysis. Okay, but now I would like to solve it using the node analysis. Node analysis. Okay, this is V1, this is V2. Shall we write directly the inspection method? Tell me. 1 by 2 plus 1 by 6. Okay, 2 to element. 1 by 7 plus 1 by 6. Who is the common element here? 1 by 6. Minus 1 by 6, minus 1 by 6. This is V1, V2 is equal to, okay, at node 1 there is only one current source which is entering. Entering current usually left side is negative but right side is positive. Therefore, plus 1. Okay. 4 amperes is leaving. Usually leaving current is positive on the left side, but right side we are sending, therefore minus 4. That's it. Simple. So solve this. V1 is equal to delta 1 by delta. I'm sure that you will be getting minus 2 volts. V2 is equal to delta 2 by delta. It will be what? Minus 14 volts. This is how you can apply inspection technique. So I'm giving all different possible ways to solve the network, so that you will get command. You must get first of all, command on the network. Okay, then only it is possible. You have to play with the networks, I'm telling you. That will come only when you see the different possibilities of solving the network. Understand? Okay, well. Now, what are the minimum number of equations required using mesh analysis in this problem? 1. Using node analysis, 2. But the problem I can solve using node analysis with a single equation. Okay, with a single equation, with the help of, source transformation. Using node analysis, what are the minimum number of equations means? The answer is 2 only. But for solving, for my convenience, I can apply source transformation and I solve this problem with only single equation. Look at this. I just transform, because there is a current source with a parallel resistor can be transformed into a voltage source, with a series resistor. Yes, Ravi Shankar, I think you don't have any doubt about the Cramer's rule, right? Please don't ask me that. I hope you know the Cramer's rule. If not, please go through the mathematics textbooks and try to understand that. Source transformation is correct, Nana? Please tell me. 4 into 7. 28 volts. I am putting minus plus because it is in downward direction. Okay, it is in downward direction, therefore I am putting minus plus polarities. And this is 7 ohm, this is 6 ohm, this is 2 ohm. You understand? This is 0, this is V1. You following? Okay. Now, I can apply directly inspection technique. V1 of, please answer it, 1 by 2 plus 1 by, you have to take the total resistance, 1 by 13 is equal to, this is entering, right? Therefore, plus 1. Okay, it is leaving, the current is leaving and touching negative sign first. Therefore, minus 28 by the 13 you are supposed to take here. Simple. So, solve it. You will be getting definitely V1 is equal to minus 2 volts. You understand, all of you? Once you get V1, you are supposed to answer that V2 also. How do you get that? How do you get that? Tell me here. You can get, when you got V1 is equal to minus 2, go back to the original circuit here. V1 is minus 2 volts. Minus 2 by 2, V1 by 2 is nothing but what? Minus 2 by 2 is nothing but minus 1 ampere. This is already 1 ampere. 1 ampere is entering, minus 1 is leaving here, okay? Then what is the remaining current flows here? 1 minus of minus 1. This is going to be 1 minus of minus 1, that is 2 ampere. 2 into 6 plus minus, this is 12 volts. Following, okay? Now, the voltage is becoming here. You're jumping from this node to this node. See, this jumping technique is how much useful. Okay, jumping technique is how much useful, just you can realize here. Jumping technique we can apply as an alternative method to current division and voltage division according to the discussion what we had. Yes, Vikram, you can also transform Vikram, that is 1 ampere, 2 ohm can also be done. But any one can be applied. It will be easy for you. Anyway, one equation is required, right? You cannot solve the problem with the 0 equations. You have to definitely go with what? One equation here. Even if you go for mesh analysis also, one equation is required to find the current, loop current. So that's why I transformed only one side. Or you want to transform on the other side also, you can do. I'm going to explain the next case. Please look at this. So what is V2 here? You're jumping from V1 to V2 by dropping the voltage, that is 12, because you're jumping from higher potential to lower potential. Yes or no? Higher potential to lower potential. That is why V1 minus 12, already V1 is minus 2. Minus 2 minus 12 is nothing but minus 14 volts. I think you got the same answer in the previous case also. Okay? Well, this is how using the transformation. Use the transformation, apply the inspection method, then use the jumping technique. That's it. So many big problems can be solved with one single equation if you understand the source transformation as well as the jumping technique. Okay? Simple way of calculating. Now, Yeah, Vikram, now I'm explaining here. Look at this. Source transformation on both sides. Here also you can apply source transformation. Here also you can apply source transformation. How it is going to be now then? It is something like this. Look at this. You can apply. There is no unique method, Vikram, okay? 1 into 2, 2 volts. 7 into 4, 28 volts. This is a 2 ohm, this is a 6 ohm, this is what? 7 ohm. Okay? This is actually V1, this is 0, this is V2. I now find the current I directly. So what is I? 2 minus 2 plus 28 by total voltage by total resistance. How much it is going to be? 2 plus 6 plus 7. 30 by 15. Yes, Ashok, 2 amperes. Very good. 2 amperes. Now when it is 2 amperes, look at this. 2 amperes, look at this. 2 amperes. What is the voltage here when it is 2 amperes? This is 4 volts. Yes or no? What is the voltage here when it is 2 amperes? This is 14 volts. Yes or no? Okay. So now, when it is 0, this is already what? 2 volts. Now jump from this node to V1. Then V1 is going to become what, Nana? 2 minus 4, nothing but minus 2 volts. Jump from this node. What is this node voltage here? Minus 28 volts. Okay. Then what is V2 going to be then? Tell me. From this node to this node you are jumping. You are jumping from lower potential to higher potential. Then take the voltage. Therefore minus 28 plus 14 will give you minus 14 volts. That's it. It's not 14 volts, right? It is minus 14 volts, I think. Yeah, 14 volts across 7 ohm. Correct, Ravi Shankar. But V2 value is what? Minus 14 volts. So the jumping technique, the beauty of the jumping technique, I think you understand here. It is very easy to analyze the networks. Understand, okay? Now, shall we solve some other different problems here quickly? Okay, find the power supplied or absorbed by each source, is asking. Find the power supplied or absorbed by each source. Okay, I told you already to join my Telegram group. Okay, for getting the PDF of this particular session and as well as previous sessions, and also the regular updates I keep posting in my Telegram group. Okay, whenever I'm going to take the YouTube sessions, I will be keeping, I'll keep informing you always, and you can also join the classes accordingly. So now find the power supplied or absorbed by each source. Tell me here. Okay, very good. Look at this. Look at this. How many loops are there here? Mesh analysis shall we apply or node analysis shall we apply? 1, 2, 3, 3 minus 2, one equation is enough. Using mesh analysis. Using node analysis, how many equations are required? 1, 2, 3. Minimum number of equations required to solve the network using node analysis 2. 3 minus 1, 2 equations. Using mesh analysis, 1 equation is enough. Best method to solve this particular problem is what? Using mesh analysis only. But I can solve the same problem using node analysis with only 1 equation. Okay? Though the answer for minimum number of equations required node analysis is 2, but I solve using only 1 equation because I am exploiting this opportunity. A current source with a parallel resistor can be transformed into what? A voltage source with a series resistor. Once the voltage source with a series resistor is formed, all these elements will become series. Therefore, there is no need to put any node. You understand, all of you? Okay? Yeah, look at this now. I'm going to solve it by applying the source transformation. Okay? Three into 1 minus plus 3 volts. This is 1 ohm, 1 ohm, 1 ohm, 6 volts, 1 ohm, 9 amperes. Is it clear? How many equations are required? Okay, this is 1, this is 2. Don't put a node variable here because the degree is 2. To put a variable, the degree must be minimum 3. Okay, you want to take variable, you can take, but unnecessarily you are increasing the number of equations. Okay, you can always create the variable only when the degree is 3. Okay, well, so now this is 0, this is V1, and we'll come back to this later. Okay, so what is V1 of? I can't take this 1 ohm because 1 is in series with the current source. Any element in series with an ideal current source can be neglected. Yesterday we have discussed this point. Any element in series with an ideal current source can be neglected. Any element parallel to an ideal voltage source can also be neglected. You understand? Okay. Well, so that two statements are very important statements, Nana. Two statements are very, very important statements. Okay. So I'm neglecting this element as far as node voltage is concerned. But when I find the power of 9 amperes, I should not neglect that element. That you have to remember. Okay. So now 1 by 1 plus 1 by 2 is equal to 9 amperes is entering. So therefore plus 9 plus 6 by 1 minus 3 by 2. I hope you understand this. I'll give you directly the value. Please note down. I think you will get 9 volts here. Yeah, V1 is equal to 9 volts. You understand, okay? V1 is equal to 9 volts. I think all of you got this answer. V1 is equal to 9 volts. Now, coming to this here, this is 9 volts when this is taken as 0. Now, my interest is to find the power of the current source. Whenever I want to find the power, I must know the voltage across the current source. In the case of voltage source, I must know the current value. Okay? So, 9, this is 9 volts. I am jumping from this node to this node because this is Vx. Okay? But what is the voltage across this 1 ohm? 9 into 1 plus minus 9 volts. Okay? Because current source is in series with the element, directly that current is passing through it. So, jumping from negative to positive, okay, you take the voltage, therefore Vx becomes 9 plus 9, that is nothing but 18 volts. Okay, therefore power of 9 amperes is nothing but Vx into 9, Vx into 9, Vx is 18 into 9, I think you get 162 watt. But look at the polarities that you got plus minus. The current is leaving from the positive terminal. Whenever current is leaving from the positive terminal, is it supplied power or absorbed power? Tell me. It is supplied power. It is supplied power. You understand, all of you? It is supplied power. Okay, whenever current is leaving from the positive terminal, it is supplied power. Whenever current is entering into positive terminal, it is absorbed power. That means that element is absorbing the power. Okay. Now, what about the power of this particular element, Nana? Okay, you must know the current flowing through this. What is the current flowing here? 9 minus, this is V1, right? V1 is equal to 9, right? V1 minus 6 by 1. That means 9 minus 6 by 1, nothing but 3 amperes. When it is 3 amperes, obviously, power of 6 volts will become 9 into 3. That means V1 into, what is the current here? 3 ampere, right? Okay. So, 6 volts into 3 amperes. So that is nothing but what? 18 watt. But what is the current doing here? This current is entering into positive, therefore it is absorbed power. Okay? This is the voltage source, 6 volts. This is what the 3 ampere. The current is entering into positive terminal. Sir, leaving from negative but entering into positive. Always think with respect to positive terminal. If current is entering into positive, it is absorbing the power. If the current is leaving from the positive, it is supplying the power. That's it. Understand, all of you? Okay? Well, so how do I find the power of this element? That I am giving you an assignment. Find the voltage across it, Vy. Vy is nothing but this is Vy. Can't you find this Vy by knowing this V1 value, jumping from this node to this node? To jump from this node to this node, I think you must know the voltage. Shall I tell you that? Okay, it is easy, right? It is already 9 amperes. This is 3 amperes. Therefore, 9 minus 3 is nothing but 6 amperes plus minus 6 volts. Yes or no? Jump from this node to this node. What is Vy value? 9 minus 6. That is nothing but 3 volts. So 3 into 3. This is what the current source. This is what the 3 volts. This is already 3 amperes. So power of 3 amperes is equal to 3 into 3, 9 watts. But current is leaving from negative, nothing but entering into positive. That means it is absorbing the power. Ravi Shankar, you are something saying I square R. What is I square R? It is power, right? I'm not talking about the power. See, in the case of voltage source, current source is V and I product only. The power I square R formula is applicable to only resistive element, not for the voltage source and current source. Voltage and current source, you are supposed to use the product of voltage and current. In case of current source, you know the current, you need to find the voltage. In case of voltage source, you know the voltage, you need to find the current. That's it. So don't apply the formula I square R or V square by R. Those are applicable to only passive element, that is resistive element. Clear all of you, okay? Well, so this is another important problem I will discuss, and okay, the remaining problems probably I can give you some assignments, okay? So look at this now. Well, this particular example, if you follow the mesh analysis 1, 2, 3, 4, okay, 4 minus 2 current sources, 2 equations required. Mesh analysis will give you 2 equations. Node analysis, if you follow as it is 1, 2, 3, 3 minus 1, 2 equations required, but it is forming a supernode. But I don't like supernode, you know that very well. As on all of you, I will try to avoid it. So for that, what I do is, I go for the reference node shifting method. I go for what? Reference node shifting method. I'm selecting this node as a reference node. Then obviously this value is going to be 2 volts, yes or no, okay? Then this value, it's not 0 now, it is an unknown value, that is V. Okay? It is V. Anjanil Nayak, superposition. SP means superposition, supplied power. Supplied power or superposition, what is that? So here can't we apply source transformation? Yes, you apply, but what is the use? Finally, are you getting minimum number of equations? That is very important. I will also come to that point. Wait, Ravi Shankar, okay? I'm coming to that point also. Okay? I think Naik is saying something. Anjanil Naik. SP means what? I didn't get your point. SP means superposition or supplied power? Please respond quickly. Okay, so source transformation, I'm going to tell you that, Ravi Shankar. Please observe here first, okay? First, I'm trying to explain you the reference node shifting method. I'm trying to apply reference node shifting method. I told you already there is no unique procedure. Anybody can solve using any method. There are so many methods you can apply. So now tell me here, V of, okay, tell me, 1 by 2 plus 1 by 4, okay, this is leaving current, therefore minus 2, okay, this is 2 volts, right? 2 by 2 you are supposed to take. You must be very careful, 2 by 2, when you are applying inspection. This is already 0 by 4, not required. But this is entering current, so plus 7. So finally, you will be getting here V value. What you get here is, I would like to give you the answer. Please verify the answer also. If you get any wrong answer, please post in my Telegram group. I told you already, Professor Muneender Gate, okay? So I'll give you the answer here. That V value is 6 volts, Nana. You will get 6 volts. V value is 6 volts. But what is actually asked here? Taking this one as 0, you got this one 2 volts already. This is 6 volts you got. But you need to answer the question by taking this one as 0. Okay, what is V1 here? If you want to make it 0, it must be reduced by 0. This voltage must be reduced by 0. If one node voltage is reduced by 0, reduced by 6 volts, okay, then every node voltage is reduced by same 6 volts, right? Therefore, 2 minus 6, this is, okay, V2 is equal to 0 minus 6. I hope you're following that. Oh, I'm sorry, actually you're getting 8 volts, okay? You're getting 8 volts. Please correct it. This is 8 volts now. This is 8 volts. So 2 minus 8. 2 minus 8 is minus 6 volt. This is minus 8 volts. Is it clear? So V1, V2 values you got it. Okay, V1, V2 values you got already here. Okay, find V1, V2 and also find the power supplied or absorbed by each source. What is the power of 2 amperes? You know very well. Okay, power of 2 amperes, V1 into 2 means 2 into 2, 4 watts. Supplied or absorbed, because this is plus, this is minus, right? Current source means you have a current source like this. Okay, this is V1, this is 0, plus minus V1. Current is leaving from positive, therefore it is supplied power. Okay, power of 7 ampere is V2 into 2, because this is V2, right? Okay, this is V2. Yes or no, all of you, go back to the original circuit. So what is this 7 into V2? 7 into V2, okay, 7 into V2 means 14 watt. But current is leaving from what? Negative, Nana. Here, look at this, negative. That nothing but what entering into positive, that means it is absorbed power. Yes, Ravi Shankar. Now, what about the current flowing through this particular element? See, you already answered the question that this is 0, this is minus 6 volts, this is minus 8 volts. Is it clear? Okay. So this is V2, this is V1. You understand, all of you? But what is the current flowing here? That is very important, Ix. I need to find the current flowing through the voltage source. Understand, all of you? I need to find the current flowing through the voltage source. So when there is no resistor, I should apply KCL either at this node or at this node. Okay, so tell me, when you apply KCL, say KCL you are applying here. Okay, Ix is leaving, 2 amperes is entering, V1 by 2 is leaving, V1 by 2 is leaving, okay, 2 by 10, this is 2 volts, right? So 2 by 10, nothing but 0.2 amperes, that is leaving, 0.2 amperes leaving, but 2 amperes is entering. From this, when you substitute V1 is equal to what? Minus 6 volts, and finally the Ix value, I will give you the Ix value. Please find that Ix value here. Please find that Ix value. That is 1.8 ampere. 1.8 amperes. Yes, Chandu, V1 is equal to minus 6. Power absorbed by 2 amperes. Current source is 2 into minus 6. You are right, you are right. You are right, Nana. Yes. It is not V1 into 2. Okay. V1 is how much actually? Yeah, V1 into 2. But what is V1 actually here? V1 is minus 6. You are correct, Nana. You are correct. You are correct. I did a mistake here. Okay. Look at this. Minus 6 into 2, minus 12 watt. Okay. Minus 12 watt supplied or absorbed? It is actually supplied. But 12 watts is absorbed. Minus 12 watts is supplied is nothing but 12 watts is absorbed. Very good, Chandu. You are correct. I did a mistake here, okay? Now, what about V2, Nana? V2 is minus 8. Minus 8 into, this is 7, right? 7 amperes. Yes. Minus 56 watt. Okay, that is absorbed power. But it is nothing but 56 watt supplied power. Yeah, please correct it, all of you. I did a mistake, okay? Chandu, you did correct, Nana. Okay, thank you, thank you. Very good, very good. I did a calculation mistake, please. I think now it is okay, right, Chandu? Yes, V2 is minus 8 into 7. It's fine now, right, Chandu? Please respond quickly. Okay, so this Ix is equal to 1.8. Now the power of this 2 volt source is nothing but, okay, what is the current actually here? Ix, 1.8. What is the voltage V? 2 into Ix. That means 2 into 1.8. 1.8. That means 3.6 watt. Look at this current. What is it doing? It is entering into positive terminal. Therefore, it is absorbing the power. Power absorbed power. This is absorbed power. Is it clear? Okay. It is clear, right? Okay. Very good, very good, very good. Okay, so this is how you are going to solve the problems, right? Finding V1, V2. Now someone, Ravi Shankar was asking that why don't we apply the source transformation. I can solve this problem using the source transformation also. Look at this, all of you. This is what the network given. I don't have to apply reference node shifting method for this problem and also super node analysis for this problem. Look at this, how it is going to be. How it is going to be. Let us see now. Okay. I don't need to apply the super node analysis. I don't need to apply the reference node shifting method. This problem particularly, this problem can be solved using, okay, look at this a different way. Can we neglect this 10 ohm? Because that is parallel to an ideal voltage source. As far as this node voltages are concerned, here V1 and V2, okay, as far as node voltages are concerned, V1 and V2, I can neglect this 10 volts. Please respond quickly. Can I neglect that 10 ohm or not? Because that element is parallel to an ideal voltage source. Any element parallel to an ideal voltage source can be neglected. But while finding the power of these 2 volts, you can't neglect it. Again, you have to come back to the original circuit. Okay, only for V1, V2 finding, you can neglect it. But for finding the power, you can't neglect it. You understand, okay? Well, very good, Ravi Shankar. Okay, Chandu, very good. Vikram, very good, very good. Yeah, look at this now. Look at this now. I can neglect this element and I can transform the current source into voltage source. Finally, the network will become very simple. Look at this. After transformation, this is going to be 4 ohm and this is going to be what? Minus plus. This is 28 volts and this is 4 ohm. This is 2 volts already. This is 2 ohm and this is 2 ampere. This is 0. This is V1. Okay. Now directly I can apply the inspection method. V1 of 1 by 2 plus 1 by 4, okay, is equal to plus 2 ampere, okay, plus 2 minus 28 by 4. Please respond quickly. Are you getting minus 6 volts or not? Okay, are you getting minus 6 volts or not? Please respond quickly. You must get minus 6 volts. Now when you jump from this node to this node, come back to the original circuit here. Okay, come back to the original circuit here. This is V1, this is V2. Jump from this point to this point. Then V2 is nothing but V1 minus 2. Minus 6 minus 2 is nothing but minus 8 volts. Please respond quickly. Chandu, I think you are getting the value that is minus 6 and minus 8. That's it, simple. Okay, so source transformation should be applied, but without neglecting this 10 ohm, there is no use, Ravi Shankar. Okay, Ravi Shankar, I think you understand that. Without neglecting this 10 ohm, there is no use. Yes or no? Okay, well, so this is how you can play with the networks I'm telling you. Okay, there are so many problems like this. This is a homework for you. I'm going to share the same PDF as it is with you. Okay, it finds so many problems. For good practice, you can really do it, and you can send me the solutions in the Telegram group. Okay, I will definitely correct if you find any mistakes. You understand, all of you? Okay, so I'll send the solutions also. I have already done the solutions. Okay, they are available with me. I will send you the solutions after few days. Okay, after a couple of days. 2 days I will wait. I think you are going to solve all these questions. The 5th question, okay, I'm going to give you here. Okay, 6th question also. Find Vxy. This is very interesting question. It was asked in one of the GATE exams. Okay, please upload your answers in the Professor Muneender GATE Telegram group channel. Okay, any newcomer, please find that. Okay, you will get it. So how many can we score with your tricks? Okay, okay. See, Naik, you can't count like that just, with my tricks, okay? See, always if you find like that, when you learn the techniques, okay, you must enjoy the techniques and, increase your subject knowledge, and then you must apply whenever you come across. Okay, nobody will tell in this world that with my technique, these many marks you will get. But I can surely tell you that all DC circuits, AC circuits, DC theorems and everything can be solved with simple techniques like this with no time, with less amount of time, and you can definitely increase the score when you come across the problem. Okay, if suppose any problem is not given in the DC circuits or AC circuits, okay, probably I think I'm not responsible for that. Okay, well. Please take some classes on network topology also. Chandu, okay, we'll take, but the topology weightage is very less, na Chandu? Anjanil Naik, I think I want out of sir. Okay, I didn't get what you're trying to say. Yeah, yeah. Okay. Chandu, actually network topology is a very simple topic. I think you are not going to get any, marks, I think, nowadays. But however, I will spend some time. No worry. Network topology you want, right? Okay. Only in ESE, I think it is very important. But in GATE, I think very rarely you are getting nowadays. Earlier, you used to get the questions. Okay. This is the 6th question. And 7th question also, find V naught dependent source problems. Actually, you're supposed to solve dependent source also. Yeah, Vikram. What is the average marks for networks? Networks, GATE minimum 7 marks. There are occasions, up to 20 marks also you got. One time you got 12 marks or 20 marks. But average I can say 12 marks, okay? 10 or 12 marks I can say. 10 marks or 12 marks. 7 marks minimum you got so far, I think. Only one time I think 4 marks or 5 marks you got. I don't remember exactly, but 7 marks is commonly being asked. But 20 marks also one time. Very rarely one time you got. But 10 to 12 marks you can expect, Nana. But I'm not understanding the topic. Don't worry, Chandu. Okay, I will explain you. I'll explain you network topology. Network topology is the ocean, actually is a big topic. But as far as GATE is concerned, okay, it is very simple. As far as IS is concerned, it is very simple. So it is combined with signals as one section. No. Signals actually is different. Signals you will be getting, a good number of questions in ECE. Networks also good number of questions you will get. Okay, though it is combined in the syllabus. Okay, generally in a GATE syllabus, they write with very concise manner. But the detailed syllabus is covered always. Networks means networks. That's it. Okay, networks means your DC circuits, AC circuit, transient analysis, magnetic coupled circuits. Magnetic coupled circuits for EC students, I think very, rarely you will get the questions. Two-port networks, network topology, passive filters. Okay, three-phase circuits are important for, electrical students, but not for EC students. But for IES, both are, for both EC and EEE, it is important. Okay, well. So what about network and analog linkages? Yes. That's what, wherever you come across a circuit, you can definitely apply the techniques, Nana. See, networks is a fundamental subject. It is useful not only in networks examination, okay? It is useful for, control systems also it is useful. Because transient analysis will help you to understand in a better way in the control systems. And network solving analysis part will help you in the analog circuits also. Okay, so where in power systems, power electronics, machines, measurements, you understand, okay, for electrical students I'm talking about. In analog we use networks, yes, network analysis can be used. Okay, power calculations, current, voltage, especially op-amp simplifications, op-amp circuits also you can simplify easily. I'm only weak in networks, sir, that's why I'm asking. Don't worry, Anjanil Naik, okay, you follow my YouTube lectures. And you join my Telegram group, I will clarify your doubts, okay? But I think I cannot discuss more at this stage, okay? But join my Telegram group. I already gave you that Telegram group channel. Please join here, okay? I will definitely clarify your doubts, okay? Where to focus, how to focus, and all those things. And all my previous YouTube lectures, you please watch. I'm sure that you will be definitely, your doubts will be clarified. Okay, fundamentals are very important, Nana. Okay. Okay, don't worry. Don't worry. One day you will definitely win the game. Okay, so like this, there are so many problems are there in this particular one. I'm going to share you the same PDF as it is, okay? And you please solve those questions. And if you have any doubts, I will send the solutions. Don't worry, okay? Okay, don't worry. You can't escape from the networks, I'm telling you. Mathematics and networks are fundamental subjects which you cannot escape. If you put your efforts, initially you may struggle, but after that definitely you will overcome. Okay, for initially you may struggle. Maths and networks are very important. Okay, if you are really master in these two subjects, you can play with any subject that you come across. So all these questions are there. Today I'm out of time. That's why I'm not able to discuss all the questions. I thought I would spend more time on discussing, but I will find one more day, okay, exclusively for solving these questions. But till then, you can please interact with me through my, the Telegram group. I'm sure that I'm going to clarify your doubts. Thank you so much for your patient listening, and I wish you all the best for your future endeavors. We will meet one more time, I mean in the near future, with one more interesting topic in the controls as well as the power systems, okay? Keep tuning to my Telegram group channel. You will get the continuous updates, okay? Thank you so much and wish you all the best.